Okay, guys, second session. Recording has started. Okay, so again, I can see it's one of those days, so let's try to finish as quickly as we can. I think we're almost done with the learning unit. Look at the slide here, we're almost at the end. If we finish, then we can look at an ICE task, which I can give you guys for homework if you want. Don't want to do it in class. Or maybe we'll do it in class together next time. We'll see. It depends where we finish. Okay. Anyway, you guys have probably finished this example by now. Let me just do it quickly. This is a combination of product rule and power rule. So first thing we do is we leave the a squared on the outside. We don't interfere with that. On the inside here, or not on the inside, on the right, we have a to the 5 raised to the power 3, which just becomes a to the 5 times 3. Right, guys, when you come in, please close the door. Someone please close the door there. Thank you. A squared multiplied by a 5 times 3 gives us 15. Now we just add these two numbers together. This is a to the, sorry, there shouldn't be a plus here. This is equal to a to the power 2 plus 15. Again, using the rule above. We're always using the rules above, product and power rule together. This becomes a to the power 15, 16, 17. Okay, did you guys all get the same thing? Okay, all right. To those very few people doing the work. Sorry, guys, I know it's easy stuff for most of you. Again, just making sure it's on the video for those who need the help as well. Okay, quotient rule. Again, this is a straightforward one. It just tells you that if you have an exponent divided by another exponent, both to the same base, you take the power on top minus the power at the bottom. That's all that happens here. So with a concrete example, this here becomes 4 to the power 9 minus 4, right? Which is 4 to the power 5. Okay, all right. Again, straightforward application of the rule. Okay, and I guess the next example is here to show us what to do if you have a number as well. 12 over 2, which we can just pull out to one side and then deal with the exponent by itself. X is the same as x to the power 1, in case anyone is confused by that. Once we have a 1 there, we can then apply the rule. No, what happened there? 12 over 2 is just 6. And on this side, we get x to the 4 minus 1, which is 6x to the power 3. Okay, a lot of examples here. 3 more. Okay, I know I am moving a bit quick. We're doing at least one example each, so we have a basis of how to do these, how to use the rules. And we will look at more detailed examples in the ICE task, which should be given today. Okay, but anyway, any questions so far that I can help anybody with? Anyone wants me to repeat anything? Product raised to a power, okay. So this is one of the easiest things, but one of the probably most misunderstood sections. So we must be careful here. This just says if you have a product raised to a power, the power distributes into the individual variables inside the product. So for example, 2yz raised to the power 6 just becomes 2 to the 6, y to the 6, z to the 6. Right? Just distributes, that's all. And we can simplify that one more step. 2 to the 6 is it 32 or is it 64? I think it's 64. I'm going to write 64. If I'm wrong, just correct me. 64 Y6 Z6. Someone just check that for us. Oh, I can check it. Correct. Okay. All right. Anybody in this maths class has a calculator on hand? Okay, 2 to the power 6. 64. Okay, so it's fine. Okay, so the one on the right is here to show us what happens when you have a negative, because sometimes people mix these up. So this, you can do one of two things. You can consider the negative to be a -1 by itself, multiplied by the whole thing, or you can consider the negative to be a part of the 7. Most people do the second one, so I will do that. So this is -7, the 2 distributes to that. We have an 8 to the 4 here, the 2 distributes to that. And we have a b, the 2 distributes to that as well. So the 2 just distributes as it always does. We know that 7 squared is 49, but what's -7 squared? 49 as well, right? Because negative times negative technically. So 49. This a to the 4 raised to the power 2 is a4 times 2 by a rule we learned above. And b squared is just b squared. So we have here 49 a to the 8 b squared. There's a point here I wanted to make, which I forgot what it was. Oh, yes. Okay. So right here, let me try and make space to make this point. Something like this. Suppose I had, instead of multiplied, we have addition here. Right? Then I see this happen often. Plus Z6. You guys think this is a fair way to distribute something? So just be careful. This is not correct. I see this happening all the time. The power can be distributed only if there's a product or a quotient. So in other words, only if there's multiplication or division, then the product can be distributed. If you have addition or subtraction, then we don't distribute powers. Then it's a different thing. Then we open brackets up and use FOIL and stuff like that, but we're not going to do that just yet. Okay, so just take note of that. Careful of that mistake. I see it all the time when I'm marking. Okay, and now a quotient raised to a power. This is most easy to understand with an example. So let's just do this one here. The power distributes to everything on the top and the bottom, similar to what we already did. So this becomes 2 cubed, x cubed, y cubed over x cubed. I mean, there's an easier way to simplify this one, but this is just to demonstrate a point here. Okay, but anyway, let's go further. 2 squared is 4 times 2 again gives us 8. So we have x cubed over x cubed will cancel, and we're left with only y cubed. Right? If you want to be very technical using the rules we learned, this will be x3 minus 3, right? The top minus the bottom. Did we learn that one already? I'm sure we did or something. Oh, good. Okay. So then that becomes 8 y cubed x to the 0, and we know anything to the 0 is just 1. Right? So it's as if that x is not even there. That's just 8y cubed. Okay, let's separate that. Okay, I'm going quicker than I hoped. If we can drag this till at least 10:30, then we can stop here. Okay, but we have one more section to do. But before that, again, let me leave this on the board for a few seconds. And if anyone wants to ask questions, please do that. Questions, complaints, problems, you just want to vent about something, you don't like your neighbor, anything, right? If you want to say anything, to let me know. Keep the time. You guys okay with each other? Yes. An edition of that. So yeah. Why can't we do that? Okay. So let's think about what happens if we do that. I'll give you a simple example. Let's say 1 plus 2 squared. Now let's see if I distribute it, if I get the right answer. So we know the answer here will simply be 3 squared, which is 9, right? We know that. But if I use the other method, and if I said 1 squared plus 2 squared. Does it give us the right thing? I don't think it does. Right here we'll get 1 plus 4, which is 5. So it gives us an incorrect thing. So it seems tempting, but it doesn't work. Yeah. Yeah, it's always safer to do it that way. Or, I mean, okay, that's one way. Technically, this also, another way is 1 plus 2, 1 plus 2. Because remember, an exponent is repeated multiplication, right? So this should give us the right thing. This will be 3 times 3, which is 9. So that one works. That works, that works, that does not. Okay. Okay, so now this is the section where most people are comfortable, but the section where I see the most mistakes as well. So we get a lot of marks for scientific notation, but it's like an all or nothing kind of situation, right? You got to get them right to get the marks. So let me start by trying to make a point here. Okay, let's first look at 2 examples. Scientific notation represents very big numbers or very small numbers in a more digestible way using base 10 numbers. So for example, if we look at this number at the top, which I don't know if I can pronounce, it's a big number, a light year, number of miles light travels in 1 year, right? It's a massive number. 588 with how many zeros? 369. 588 with 10 zeros in front of it. It's a massive number. That is more, it's better to write it in this way, 5.88 times 10 to the 12. If you put it in your calculator, you'll see it's the same number. Okay, and small numbers, it's a similar thing. Like this number at the bottom, the diameter of a hydrogen atom is a tiny number, very small. So writing it in scientific notation like this makes it more easy to digest. Right, we'll see how to do that in a moment, but I'm just showing you guys what it is. And let me just think of an example here. Suppose I had something like 0.2 times 10 to the power 5. Would you guys agree that that's scientific notation? Right? Looks like it, but we have to be very careful here. This is where there's a slight problem with what we may have already learned. We haven't gone into too much of detail before. Scientific notation, this first number needs to be a number between 0 and 10. Okay, wait, let me write this better. This needs to be a number between 0 less than, I'll call the number A, less than 10. 0, not 0, 1. Less than equal to 1, less than 10. 1. So that's the rule now. Who's talking to me? Sorry. Well, the other way is mathematically correct, but it's just the way we define scientific notation. Right? This here, as it is perfectly logical. There's nothing wrong with it. But usually we just want to be consistent with the way the rest of the world does this, and this is just how we define scientific notation. Okay, so that's the first problem. Second problem could arise if instead of a 5 here, I had, let's say I had a half there, right? Then it's not scientific notation. So the criteria for this number here is that it needs to be, I'll say, element of integer. It needs to be an integer. And so these are 2 things we need to remember, which are summarized down here in this blue box. Scientific notation, if you have something like A times 10 to the n, A needs to be between 1 and 10, n needs to be an integer, right? So that's not difficult to remember. It's one of those things, once you see it, you can't unsee it. Okay. Everyone with me? Okay, perfect. So now I think we can finish in the next 15 minutes by doing a few examples with scientific notation. Okay, the first number, 1.85 times 10 to the minus 2, is that scientific notation? Looks like it to me, right? It's because it meets the criteria of the first number being between 1 and 10, and the exponent is an integer. Perfect. Second number, is that scientific notation? People saying no, right? That's correct. It's not. Which criteria does it not meet? Not an integer, right? Exponent, not an integer. Okay. The third number? No, right? First criteria not met. Number. Okay. The last one? Sort of a tricky one, right? You're saying no for this one. No, the reason being because 10, yeah, the first number, right, is 10 is not less than 10. Right? So it's tricky, but this number here is the problem. That needs to be less than 10, not 10. Okay. It's a less than equal to problem, basically. Okay, I'm not writing here because I'm talking, and in the video, the thing will be there, the explanations. But then again, just check the criteria. It's all right here, in case you guys lose it. Okay, also, oh, the solution is right here as well. So not sure why there are decimals here, but anyway, it doesn't matter. Just a few quick examples of converting numbers to scientific notation. If you've not done this before, I'll go over it very quickly to explain the rule. This thing you can find anywhere, YouTube videos and stuff, a lot of places you can find explanations for this, but I'll do it one time as well. So a large number converted to scientific notation, for example, 500. This number is 500. I don't know why they say 500.0. The point doesn't do anything for a large number. It's unnecessary. So you can, let's just say right now, this point, we can just ignore it. Now what happened to this thing? What happened to my pen? Okay. Ignore. Can this thing please stop disturbing me? Ignore the decimals. Okay. But for small numbers, we can't ignore decimals. For large numbers, we can. If it's a 0, we can ignore it. So for these, we can ignore it. Okay, so we'll write this first number as 5 times 10 to the power. That's the basic structure of it. A number between 1 and 10 times 10 to the power something. How do we determine that something? Well, we start from the point just after our number, which is 5, and we just count to the end. 1, 2, we moved 2, so the 10 has a positive 2 on top. You guys have all seen that before? Okay. If not, just familiarize yourself with it. The second one here is 8 times 10 to the power what? Let's check. From the 8, we go 1, 2, 3, 4, 8 to the power 4. Okay. This other one, you guys can tell me, what will that be? I heard the first part correct, 4.3. Some people go 43, but that's not correct because that's not a number between 1 and 10. So just be aware of that. Right, yeah, so that's a common mistake. Be aware of that. So now we 4.3, so we start counting from 4.3, from in between here. So 1, 2, 3, 4, 5, 6, 7. So 10 to the 7. Okay, and similar thing at the bottom here. This is going to be 6.25. Thank you. Times 10 to the power. Only God knows. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Did I count that right? I think so. Looks good. Okay. All right. Let's do the small numbers. Small number is a similar thing, except now we have negative exponents and we kind of count backwards. So here, similar thing. 5 times 10 to the power. So from the decimal to the front, we go 1, 2. So 10 to the minus 2. Okay, same idea. Let me just do another one. 8 times 10 to the power 1, 2, 3, 4, minus 4. Okay, you guys get the picture, right? Do I need to do the rest? No, okay. You guys want to see me do any of the others? Just let me know. Last one. Okay, let's do the last one. Might be a bit tricky. So 6.25 times 10 to the power. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I stop where the decimal is on the 6.25. So I counted 10 there, right? Okay, we're all right. Good question. Yeah, so these ones can get a bit tricky. Okay, also the solutions are down here if you guys want to check. And there's an explanation here of the method I just explained if you guys want to see the written version of what I've spoken to you guys about. 2 examples. Okay, we can finish off with 2 examples in 10 minutes. And these examples show us, okay, this section is easy, but I always see mistakes with these. So I'm going to be very careful here. Firstly, the reason that we learned exponential rules before this is because these are exponents. We have 10 to the 8, 10 to the minus 13 exponents with a base 10. So whenever you see these, we need to use exponential rules. What I often see is people will write equals to, and then they'll just write some big number the calculator gave them. I mean, I can't give marks for that because this You need to check whether you know how to write an answer in scientific notation. So general rule, if you're given a question where the numbers are in scientific notation, the answer must also be scientific notation. And you've got to get to your answer using exponential rules. Right, so no calculator work. I mean, you can check in between, obviously, but you got to show your exponential working. So this, for example, first common mistake I'll mention is people use FOIL to open these brackets. Right, we can't do that because technically this is all multiplication. So it looks like a FOIL situation, but this is the same as 3 times 10 to the 8 times 6,8 times 10 to the minus 13. There's no addition here, there's no subtraction, it's only multiplication. It's this times this times this times this, right? Because it's as easy as that, right? You guys good with that so far? So from here it becomes easy because we just keep the base 10 numbers to one side, we'll keep them to the right, and all the other numbers we keep to the left. 3 times 6,8 I'll keep on this side, and this side we will take the 10 to the 8 times 10 to the minus 13. Now we can use exponential rules. This 3 times 6,8, you can use the calculators for that. 20,4, thank you. 20,4, let me try not to fall down here. 20,4 times 10 to the power, this will be 8 minus 13. So that is 20,4 times 10 to the 8 minus 13 minus 5. Thank you. Okay, but we have to be careful here because this looks like a good stopping place, but is that technically scientific notation? It isn't, right? Because it's 20,4. It's not a number between 1 and 10. So we've got to move the decimal around. And now this is where a lot of people get confused, including myself sometimes. You've got to be very careful with these things. You can write the answer one time, or let me just go very incrementally. You can also write 20,4 in scientific notation by itself and see what exponent you get. Then include that exponent with the one we already have. Some people prefer that method, right? That sometimes works. So can I ask you guys 20,4 by itself in scientific notation? What would that be? I don't know. I will start with the 2,04 times 10 to the power something, right? Forget about the 10 to the minus 5. I'm just asking 20,4 by itself. Right? Anyone knows what that would be? Move the decimal 1 point backwards, right? So that means we should have a negative exponent. Minus 1. Is that right? We're moving 1 back, right? I'm not worrying about the 5 yet, just this number. So we move 1 back, so we get a minus 1 here. And this 10 to the minus 5 is still there. So I just worked with the 20.4. And then now we can combine the two exponents. I wrote the wrong thing. As 2.04 times 10 to the minus 1 minus 5. 10 to the minus 6. Is that right? Okay. I feel like something went wrong somewhere here. Okay, are you guys all okay with that? Everything seems fine. Okay, let me just think for a second. Okay, if you guys want, you don't have to do this extra step. You can go straight from here to here in one step. If you can't do that, yes. Minus 4. Yeah. 8 minus 13. Minus 4. So we're supposed to get a positive one for the exponent. Okay, yeah, see, these things sometimes happen. Let me just think for a second what happened there. So if I move the decimal 1 point left, yeah, you're right, 10 to the positive 1. 10 to the positive 1, okay. So yeah, that's why I said be careful with these guys, because it's easy to make mistakes with these. This should have been a positive 1. Positive 1. So minus 5 plus 1 gives us minus 4. Yeah, that seems right. Okay. So now I was supposed to show you guys the long method. Now I'm going to show you guys a kind of cheat way to remember this. Once you get to this point here where you see clearly you got an answer, it looks okay, but it's not scientific notation. Let me use a different color for what I'm doing now. Then the easiest way to then get a final answer is to say, okay, 20.4, to convert that to 2.04, you move the decimal left, meaning you're making the number smaller, right? 20.4 to 2, so 20 to 2 is clearly getting smaller. Since it's getting smaller, you must compensate by making a positive 10 or a 10 with a positive power, right? So it makes sense here because we've got a 10 to the positive 1. That's how you remember whether the thing is negative or positive. So again, I'll say that again. 20.4 is becoming 2.04. So I'm turning 20 into a smaller number. So I must compensate by including a 10 with a positive number. I'm going smaller with the 20, so the 10 compensates by being a bigger number. Right, okay. So this 10 here will be a 10 to the 1, and then a 10 to the minus 5 is still there. Right, and then, yeah, you guys know the story from here, 10 to the minus 4. Okay. Any questions so far? All those people correcting me, thank you. It's very helpful. And the last example is quite an easy one, so we can do this one quickly. This is just to show us what to do a division. This will just become 2.829 over 3.45 times 10 to the minus 9 over 10 to the minus 3. You just separate these two things. All right, and now the number on the left, I don't know what that is. We have to check with the calculator. 0.82, thank you. 0.82 times 10 to the power minus 9, top power minus the bottom number, minus 9 minus 3, which is the same as 0.82 times 10 to the, I'll just write it for the sake of showing this, plus 3. Now we're coming here, let's divide this, so it's not, okay. 0.82 times 10 to the power minus 9 plus 3 is minus 6. Now we've got the same problem we had the last time, right? The answer looks fine, but it's not technically scientific notation. So we got to move the decimal point 1 point to the right this time. So we're making the number bigger. 0.82 became, I just wrote the same thing, didn't I? Sorry. 8,2, thank you. 0.82 became 8,2. It became a bigger number, so we compensate by making a 10 with a negative exponent. All right, we move 1 point to the right, so we compensate with a 10 with a negative 1. And our 10 to the minus 6 is still there. So this becomes 8.2 times 10 to the minus 7. Okay, and again, if you guys want to move, I think we'll just hurry up for me. Move straight from here to here without the intermediate step, that's fine. We can do that. Okay, timing is very good today. 11:29, and anyone has any questions, problems, complaints? All good. Okay. All right, then, guys, the next time I see you, do you guys want an ICE task for homework, or do you want to do it together in class next time? Class, okay. So we'll use the 2 hours for the ICE task. Okay, so please bring pens and pages and stuff like that, because afterward I'll check and I'll give you the mark here in class for having done the task. Okay, all right, then thank you guys. I will see you next time.